Welcome to Wednesday. I'll let you guys know that Friday is not mandatory. I know some teachers are doing Thursday and Friday is mandatory this week. We're going to cover everything we need to today. Friday, I'll be here in class, but it's optional. If you need help, come on by. I'll be here. But otherwise, it is not a mandatory class on Friday. So today, since we didn't have Monday, we need to go through our lesson today. So that's why we're here today, but not Friday. It is an A day this week. They rearranged the AB schedule because of the weather. So it is an A day this Friday. I do want to start off with a video today, something non-math related, because I love these type of videos. We need more of this in the world. So I'm going to show you this. We need more of this. I'd love if somebody would do this here. They should do this at school. They should do this down the town square or something. So let me show this. It's about 5 minutes, and then we'll get into our lesson for the week. But really cool stuff. I'll show this video.
I have never, ever been in a ball pit before.
What?
You've never been in the ball pit?
Nah, never.
You gotta go.
No, I've seen them, but I've never been in one.
You know, I remember these ball pits because my kids threw up in them.
Yeah.
Okay.
All right, so let's see.
Okay, this is a good one. Share 3 things on your bucket list.
First one is to go skydiving.
I want to go skydiving.
Have you ever had those dreams where you're just like floating and, you're flying and everything? Scuba diving is just exactly that.
Don't you get afraid of drowning or being underwater or getting attacked by an octopus or any of those things?
I want to learn curling,
What is it?
like that Winter Olympic sport.
Oh, all right, where you slide the
Yeah,
puck thing?
and then it's like bowling and sweeping.
Find one thing you have in common. Do you play sports?
Not currently. I play soccer, so.
Soccer?
Yeah.
All right.
Actually, I play the drums. Do you play any instruments?
I quit everything I ever tried.
All right.
Actually, fun fact, these aren't real teeth. Yeah.
I have a flicker tooth.
Really?
Ah! Oh my God! No! I can't. Wait.
What?
My front tooth.
Oh my gosh.
Ah! You don't even understand. I swear to God, I feel like someone planted us here for this reason.
Destiny.
Describe the first time you fell in love.
Oh, I think it was kindergarten. I don't remember his name, but he was beautiful.
I was in the Navy,
You were in the Navy?
and my husband was in the Navy. Long story short, before he ever kissed me or we were ever really together, he told me he loved me. 24 years later, we're more in love and we're better friends than even from the very beginning.
That's true love in its finest. Talk about someone who inspires you.
Is it all right to talk about somebody that's a religious character?
Yeah, why not? This is our ball pit. We can talk about whoever we want, right?
Jesus.
All right.
Just my peers. They're all creative in their own ways and have their own realities and own lessons. I just grow from everybody else's as well as my own.
Martin Luther King, I think, because the fact that we're sitting in this box together is a big deal, you know? Like,
You know who inspires me, believe it or not, is my daughter. She is everything I ever wanted to be.
All right. Talk about the experience that changed your life. Oh, that's a good one. After my wife decided that it was time that we split, I started to have a different perspective on life. I saw women differently. I saw relationships differently. I think I became more appreciative of women.
How old did you say you are? 20?
Yeah.
Okay. At the age of 21, I was diagnosed with multiple sclerosis. And it pulled the rug out from all my plans. It really changes the way you look at things.
My grandmother has it.
Who does?
My grandmother.
There's our comment.
We found the comment.
We found the comment.
That's why I was still here. We found the comment.
oh, create a secret handshake. Okay.
Okay, but nothing with spit.
Okay, so that.
I need both hands.
Okay.
So this.
And then whoever gets on the top makes a flag.
Oh, now I forgot what it is.
And then like maybe a little twitch in the middle.
1, 2, 1, 2. High 10.
All right, we did it.
Awesome. I actually had a lot of fun. I was a little bit nervous because normally you don't hang out with strangers in ball pits. I got to learn some pretty cool things about you.
It was really nice to meet you.
You too.
I hope I see
I'll
you
take a
again.
hug.
Okay, I love it.
Wait, I'm really impressed by you. I was worried that I would start talking to you like a mom. I don't know if I did.
No. Nah, you didn't. Trust me. You did good.
Super gay, get subscribe.
Wouldn't that be cool? Come along, you come across this ball pit, and big sign, have a seat, make a friend. You get in there, somebody you don't know, and just share. Cool thing. I just thought that was neat. I thought that was really neat. So wanted to share that today. Just get us started on a good foot there. Get us started in the right way. So yeah, I just thought that's neat. I love those kind of videos. It's just kind of random. I said that'd be really cool if they had one of those in the cafeteria, where you don't get in there with a friend of yours, you get someone you don't know. So something to think about. Something to think about. They got some other ones where they do some different kind of things as well. They have one where they just built on the street, where you give someone a compliment, and they had like a phone booth over here, and over here just great big huge headphones. The speakers were this big, and it looked like a big set of headphones, and you just stand in between it and the person in the phone booth over there. They have a microphone, and they're giving you and they're just telling you what a compliment, and that was really cool. Just out in the street, random, and so people would do that. So all right. Like I say, Soul Pancake. They got a lot of those kind of cool videos. Let's get into this week's lesson so we can say we did something today, right? Yeah, no, we're in here. Let's see. Today is first hour right here, Algebra 3, first hour. Let's look at our grade screen as usual. So last week we had arithmetic sequences. That's where we learned formulas to find, like if we have a sequence that goes 2, 4, 6, 8, and we want to know what's the 41st term, we had a formula that we could do that to know what the 41st term would be. So today we're going to learn about arithmetic series. What's the difference between a series and a sequence? And we're also going to look at geometric sequences. We have 2 lessons this week. So let's get into it. 5.02, arithmetic series. All right. So here's an interesting way to look at this. So if upon opening your first savings account, you made the initial deposit of $25, right? It's like one of those kids savings account, you get $25. I think I had $37 when I first opened mine, or 27. I got birthday money. I had some 5s and some 1s. I took them down, opened up my first savings account. So this says each month for the next 5 years. Oh, that's 60 deposits. You increase your deposit amount by $15. That's not saying you deposit $15. That's saying every month you're depositing, and every month you're depositing $15 more than you did last month, because you're increasing your deposit $15 every time. So you deposited $25 the first month. A month later, you went back and deposited $40. And then the next month you went and deposited $55. And every month you're increasing your deposit. So your knowledge of arithmetic sequences would help you find out how much you deposit each month, right? Because we know, okay, how many at month 36, we have a formula that we can say how much would that be if it increased $15 every time. But how much money would be in the account? That we don't know. We'd have to add all those. We'd have to figure out all 60 deposits and then get a calculator and add them all up, right? Except for today, we're going to learn about arithmetic series. That's when we add them together. The difference between a sequence and a series we're going to learn is a sequence. Those numbers are separated by commas, right? 25, 40, 55. But a series, they're separated by plus signs, because with the series, we add those numbers together as they come along. 25 plus 40 plus 55 plus 70. Every month we're adding them together. So that's the difference between a series and a sequence. So to give us some of these sample stuff here, is this a sequence or a series? Well, these numbers are being added together. We did look at this sequence last week for 14, 24, 34. We briefly talked about that. That was a sequence. But if we're adding them, that makes it a series now. Here's another sequence that we looked at last week. 3, negative 147, negative 297, negative. This is where it was subtracting 150 every time. So we're adding a negative 150 or subtracting 150. Sequence. We're not adding those together. 1, 2, 3, 4, 5. Sequence. 10 plus 8 plus, well, there's a plus. That's a series, right? So the only difference is either adding them or just listing them. But either way, they have that common difference. Plus 10, plus 10, plus 10. You know, this is 4, 14, 24, 34. Every time it's 10 bigger than the one before that. This one's negative 2, 10, 8, 6, 4. Every time it's getting smaller by 2. But series, we add them up. So it's not that difficult to do. So, all right, we're going to look at something that they're doing here. So I'm going to write this on paper. You can watch the video on your own if you want to watch it later. But they do something interesting. I like the way they do this is kind of a different way of thinking about a sequence or a series here. So I didn't write that very big. I need to work on that. Okay. So we have a 4, a 1, a 2, negative 5, negative 8, negative 11. So that's obviously a sequence, but we got a plus sign in between all of them. So let's look at it like this. Let's take the first one and the last one and add those together. 4 plus negative 11. That would equal negative 7, right? Okay, let's look at the next two. So if we took the 1 and the negative 8. 1 plus negative 8. That's also negative 7. How about the next two? Negative 2 and negative 5. Negative 2 plus negative 5. That's also negative 7. So what we can see is each time we took these pair, the first and last, the next to the first, next to the last, the next to that one, next to that one, they're all adding up to the same number, negative 7. Very odd, very peculiar, but it kind of gives us some idea on maybe a way we can add up the whole thing. So what we can see is if we take the first and last one, how many are there? 1, 2, 3, 4, 5. There's 6 numbers in this sequence. How many times did we have to add them together? Well, half, because we're taking 2 of them and putting them together every time. So that kind of gives us the number divided by 2 is how many times we did this. So it kind of gives us a start on maybe a formula for this, perhaps. Let's see what they did with this afterwards. So I said, notice each pair of terms adds up to the same number, negative 7. So finding the sum of the series is now easier because if we just add up these then, because we added these together, added these together, add these together. So if we just add all this together, that's what all those numbers would be if we add them up. 4 plus 1 plus negative 2 plus negative 5 plus negative 8 plus negative 11 equals negative 21. Because here we've added them all up. There's all 6 of them added up. Negative 21. It's like, Okay. So we're seeing a little bit of a shortcut there. We just multiplied the negative 7 by the number of pairs. 3 times negative 7 was negative 21. So let's look at the terms again before we get into the formula we're going to come up with here. These are the terms that we use when we talk about arithmetic sequences and series. It's the same terms we used last week. A sub n, A sub 1, n, and d. And here's the definition. So we're going to match these up. So d, if you remember, was the common difference. Like when we look at this sequence that we have right here, what's the common difference? 4 to 1, that's subtracted 3. 1 to negative 2 subtracts 3. Negative 2, negative 5. So our common difference is negative 3, because that's how much you add each time to get the next number. So we still use that same terminology, common difference between terms. All right, n, that means that's the number of terms in the sequence, right? We looked at n, here n was 6, because 1, 2, 3, 4, 5, 6. There's 6 numbers in that sequence. Number of terms in a finite sequence. A sub 1, that's what we call the first one, the first term. It was 4 for the sequence we're using. And A sub n is the last one. A sub 6 would be the 6th term in that sequence. So uses all the same terms that we used last week. So let's look at this. Using some or all of the variables, A sub n, A sub 1, n, and d, let's write an expression that would allow us to find the value of negative 7 from this series. Right? Well, since we have those terms, we have A sub 1 was 4, A sub n, when n was 6, so A sub 6, since n is 6, would be negative 11. So we can get this negative 7 by adding A sub 1 plus A sub n, the first term and the last term. That gave us the negative 7. And if we multiply that by n divided by 2, which n was 6, so this would be 3 times 4 minus 11, or plus negative 11, either way, right? Which would be 3 times negative 7, negative 21. Hey, we have a formula here. Arithmetic series. I'll highlight that. What's the S? S is sum. The sum is what you get when you add everything together. So if we had the sum of this 6-term series, the sum of the first 6 terms would be 6 divided by 2, and the first one plus the last one. Multiply times the first plus the last one. Pretty cool. We were able to figure that out looking at sample sequence right there. Let's go back and see what Buzz has to say. So theirs said, all right, A1 plus AN, by adding the first and last terms, you find the sum of each pair of numbers. That's what we did, the negative 7. And you know it's being multiplied by 3, so we can take the number of terms divided by 2 and get the 3. Let's go to the next page. They're going to put it all together for us. Oh, they're going to work backwards with this video. You can watch that video later, but it's going to get the same thing. We're going to get to the sum of this series. You take the number of terms divided by 2, multiplied by the first plus the last one added together. That is the sum of a series. So let's look at another thing. Now this would work great. This will work great if you know the first term and the last term. Right? The first term and the last term. But what we learned last week is sometimes they give us a problem to where, let's say, A sub 1 is 3, and the common difference is 6. And we want to find if we had 40 terms. If it starts with 3, goes up by 6 every time, and there's 40 terms in the sequence, what's it all add up to? Well, we have a formula that we can add up a whole sequence now, right? But here's the problem. We know what n is. It's 40. So sum of the first 40 terms would be 40 divided by 2, 20, times 3 plus the 40th term. We don't have the 40th term. This is a problem. This formula won't work for us without knowing the 40th term. But we did have last week, we had a formula to find the 40th term. A sub 40 was, remember what that was? We took the first term, 3 plus 40 minus 1 times 6. We took n minus 1. So our formula was a sub n equals a1 plus, and we can put the d in front of it or back. I'll do it the way they did it on Buzz there. The 40th term is the first term plus n minus 1 times the common difference. 40 minus 1 times 6. So if this is the last term, this is what the last term equals, all right? We can modify our formula for this situation without having to find the 40th. I'm not even going to do the math. I don't want to know what the 40th is because I want to fix this to where I don't have to do this every time. So let's take this formula, the sum S sub n, make S look better, n divided by 2 times a1 plus a sub n. Again, I don't know a sub n, but I know what it is. Let's substitute this in for a sub n. So a sub 1 plus n minus 1 times d. See that? I just substituted this in for that. Otherwise, it's the exact same formula. But since that's what a sub n equals, I can do that. So all we have to do is simplify this now. So now we have S sub n equals n divided by 2, a1 plus a1, 2 a1s. A sub 1 twice, so 2 of them, plus n minus 1 times the common difference. So now we have a formula we can use when all we know is the first term, the common difference, and the total number of terms. This works for this now. So if we want to know the 40th term or the total of the first 40 terms, because this is the sum, the total of the first 40 terms, that would equal 40 divided by 2, 2 times the first term, which was the 3, plus n minus 1, 40 minus 1, times the common difference. We know the common difference is 6. Okay, let's simplify. So that's 20 times 6 plus 39 times 6. Well, let's get our calculator out. Here we go. So what's 39 times 6? So this is 234 plus 6. So this is 20 times 240. So it equals 4,800. If we start at 3 and go, let me move the calculator. If we start at 3, add 6 every term, all the way up to the 40th term, and then add all those numbers together, 4,800. That sounds really big, but if you're adding 6 every time for 40 terms, that 40th term is going to be pretty big. Now let's see what the 40th term was, because we're adding 3 plus 9 plus 15. By the 40th number, see, 40 minus 1, so that's 39 times 6 plus 3, 237. So the 40th term, a sub 40, is 237. So yeah, it could add up to 4,800, because the 39th term would be 231, and the term before that is 225, and the term before that is 219 and 213, because it's just 6 difference, right? This is the 40th, the 39th, 38, 37, 30. So right here, we've got over 1,000 with the last 5 numbers. So yeah, it probably does add up to 4,800. In fact, we know it does, because this is our formula that will tell us that. So in your notes this week, and remember, you can use your notes for quizzes, tests, all the assignments. You can always use your notes. These are the 2 formulas you need to have in your notes. S sub n equals n divided by 2, a1, an, a sub 1 plus a sub n. Or n divided by 2, 2 times a1 plus n minus 1 times d, all that multiplied by n divided by 2. So I'd have those in your notes, and I'd have an example so I can see how it works using those equations to make sure I understand what it's doing. So that is arithmetic series. Let's see what else Buzz is. Buzz has these formulas as well. So here is the second formula that we did. So there was the first formula right up here, arithmetic series formula. And then when you don't know what the a sub n is, you don't know the last term, then you have this one. S sub n equals n divided by 2, 2a1 plus n minus 1d. That's the second one that we did. All right, let's see what they have on the next page. But that's the 2 formulas right there on page 3. And there's the lesson summary. See, that was it. Gives you the 2 formulas. Talks about what an arithmetic series is. That's all we learn really in 5.02. Now you have some example problems to work. Find the sum of a 26-term arithmetic sequence where the first term is 6 and the last term is 231. That's where you're going to use that first formula. N divided by 2, first term plus last term. So here's some examples where you can work it and make sure you get the same number they get. That one does it in the video. They give you the problem. But work it on paper first and then check the answer. This one, which formula would you use for this information? Which one of those formulas? And it'll tell you if you're right or wrong. Does it have more of those? I can't tell behind there. Okay. There may be multiple, it looks like, maybe down there. But do this and see, do you know which formula to use? Example 4 gives you as a table. 1, 6, 2, 8, 3, 10. So the first term is 6, the second term is 8, the third term is 10, the fourth term is 12. So here's your sequence. And then when I add 10 more rows, try to figure out how many more chairs you need. How many chairs you need for the whole wedding? And then here's the last example. So try those, see if you get the right answers. Here's another page of practice problems on page 5. They always give you plenty of practice to where you can figure out, do I know what I'm doing? Do I know it? What's the sum, the total of a 44-term sequence? First term, -9, last term, 120. Calculate your answer on paper, submit. It's got 4 of those. Then it's got activity 2, first term of a 14-term sequence, where the last term is -12 and the sum is 40. They give you the sum this time, and you got to figure out what the first term is. They don't give you the common difference. But you can use that first formula, plug in what you know. In fact, let's do that one together, just for you folks that are like, I don't know what I would do. All right, so we would use the formula S sub n over 2 a1 plus a n. And so this says it's a 14 term. And A1 is what we need to know. A sub 14, it says the last term is negative 12. And the sum of the first 14 is 42. All right, let's put that up. Okay, so it says you have 14 terms. You need to know what the first term is. A14, the last term, it says is negative 12. And the sum, that's a S, sum of the 14 is 42. So if we use this formula, we can't use this one because we don't know the first term and we don't know the difference. We have to know everything but one term to solve it. We wouldn't be able to solve that. This, we know what n is. We know what a sub n is. The only thing we don't know is that. So when you can just have one missing variable, we can solve for that variable. So let's substitute what we know. S sub 14 is 42. So the sum is 42. N divided by 2. We know what n is. It's a 14-term sequence. So this is 14 divided by 2. So that's 7. We don't know what a sub 1 is. That's what we're trying to figure out. But we do know a sub n, a sub 14. All right, let's solve this for a sub 1. Well, you can say solve for x, really, because that's what we don't know. So the first thing, order of operations, we have to distribute. 42 equals 7 a sub 1s. 7 times negative 12. Negative 84. Okay, so we have 42 equals 7 A1s minus 84. Trying to solve for A1. So let's move this over to the other side. 126 equals 7 A1s. So divide both sides by 7. And we'll have A1, because these will cancel out. A1 equals 126 divided by 7. If you don't know that off the top of your head, which some of you might, I hope you do, 126 divided by 7 is 18. 18 right there. That's the first term. So the first term's 18. The last term's negative 12. Get rid of that. So the first term is 18. The last term's negative 12. So this is the sequence that goes down. 18 dot 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 negative 12. We could figure out the common difference because there's 14 terms between there, but we won't. We'll save that for another time. That's not what we were asked to do. All right. So we know 18 was the first term. Submit. Correct. And then they showed you exactly how to work that, which is exactly what we did. 42 equals 14 divided by 2 and negative 12. We substitute what we knew. Simplified that to 7. Distributed that. Moved the 84 over. Divided by 7. Come up with the 18. So there. And then they got more there. What is the common difference? So this one, they tell you the first term and they tell you the sum and they tell you how many terms. So you can use that second formula there and solve for D. All right. Let's look at the assignment that goes with this one. You have first and last terms of a 10-term series. What's the total? What's the sum? So this here's the first term, there's the last term. Use your formula. Identify the 33rd term of this sequence. You can figure out what the D is, but it wants to know the 33rd term. Oh, so this one you got to go back to last week's formula. Because it's not asking you the sum. It's asking you what's the 33rd term. You never have to retake. You only get one shot. This is starting out the savings account with $9. Every month he's deposited more money than the one before. And at the end he has this. So how much more do you deposit? What's D? What's the common difference? Fill in everything in the formula except for D. Solve for D. Each level smartphone app adds more gems for you to match. Level 1 is 13. Level 12 is 123. What's the sum? When you finish all 12, how many total gems did you match? That's the sum. Use the formula with the first and last terms. And then the seats of a baseball stadium arranged so each row has 5 more seats than the one in front of it. It gets wider as it goes up. If there's 4 seats in the first row, how many are in the first 24 rows? How many total seats are there? All right, so you have the common difference. Each row has 5 more, and you have the first one, so you can use the formula for that. All right, that's arithmetic series. We're going to go to 5.03, which we're also doing, and this is geometric sequences. More sequences. But this is geometric, not arithmetic, so there's obviously a difference. All right, find the next 3 terms in this sequence. 1, 4, 16. I'm going to open up the chat for that. I'm going to wait and let you guys give me the answers. We'll type them in once you have it. Find the next 3 terms. If it starts with 1, 4, 16, what's the next term? What's the term after that? What's the 6th term? There's the 4th, 5th, and 6th terms. This is when I find out who logged in and then left their Chromebook and was in the other room playing video games and is not actually in class. All right, let me look at all these answers. Wonderful. 1, 4, 16, 64, 256, 1024. I see lots of agreement. Let's type those numbers in. 64, 256, and 1024. Submit. Oh, you guys did wonderful. So obviously you figured out what was going on. It didn't add because that'd be 1 plus 3. What that 1 plus 3 there, that's 12. So it's multiplying by 4 every time. So 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. 64 times 4. All right. Great job, everyone. We won't do all of these. I was just... Oh, actually, I do want to do this one because this looks weird. 2, -6, +18. What's that, Mr. Brock? What? Yeah. It is multiplying by the exact same number every time, which is what we need. It has to be the same number for it to be a sequence, to be a geometric sequence. Geometric sequence. So what numbers are multiplying by, and what are the next 3 numbers in that sequence? So if you're not sure what it's multiplying by, just go backwards and divide. Divide -6 by 2. Divide 18 by -6. Just divide by the one in front of it and see. So -6 divided by 2 is -3. That's obviously is multiplying by -3. 2 times -3 is -6. So does that hold true? -6 times -3 to give you the next term? Yeah, it's a negative times a negative, so it does turn positive. This is one of those sequences that alternates positive, negative, positive, negative, positive, negative, positive, negative, because it's multiplying by a negative. So when that negative is multiplying a positive number, it gives you a negative answer. But when you multiply a negative times a negative, it gives you a positive answer. Back and forth, back and forth. Anyone got the next 3 terms? Anyone got the next 1 term? I'll take it. Carmine's on it. He's got it all figured out here, see? 18 times -3. All right, I'm seeing several people with the same answer. -54. When you multiply that times -3, you get a positive 162. When you multiply that by -3, it's -486. Submit. Perfect. So geometric sequences. It's similar to an arithmetic sequence, but an arithmetic sequence is adding or subtracting, right? Let's adding a negative number, which is the same as subtracting. See, arithmetic adds, geometric multiplies. All right. So we're not going to call this a common difference. because a difference is when you subtract. All right, so let me put this up here. So the common difference is when you subtract, right? What's the difference between 5 and 10? Well, if we subtract 10 minus 5, the difference is 5. This, since we have a sequence, 1, 4, 16, 64, for example, we'd have to divide, right? So this is a ratio because 4 divided by 1 is 4. 16 divided by 4 is 4. So R is our variable for ratio, R. So we use D for difference when this is arithmetic. Arithmetic uses D. R is geometric. Geometric sequences use R. So that's the difference we're going to see in our formulas here. All right, let's look at page 2. Sharpen my pencil while it's loading. All right, geometric sequences. It's a list of numbers called terms which share a common ratio. So, all right, so this is, we have to identify, is this a geometric sequence or is it not? If it's not a geometric sequence, these formulas we're going to learn won't work, right? This only works for geometric sequence. 4, 12, 20, 28. Yes or no? Is that geometric sequence? 4, 12, 20, 28. Put that in the chat. Yes or no? Is this geometric? Does it have a common ratio? Is it multiplying by the same number every time? No. I'm seeing no's there. Good job, because this is adding, right? 4 plus 8 is 12. 12 plus 8 is 20. 20 plus 8. That's an arithmetic sequence. It is a sequence. It's an arithmetic sequence, but not geometric. How about this? 5, negative 15, negative 90, 270. Yes or no? It's definitely not an arithmetic sequence. Is it a geometric sequence, though? Carmine says no. Because you'd have to, well, let's see. 270 divided by 90, that must have multiplied by negative 3. Negative 15 by 5, that was multiplied by negative 3. But what about negative 15 to negative 90? That's times 6. It kind of looks like a geometric sequence, except for those middle two terms. That is multiplying by 6. So this is not 1, 1, 2, 6. No, that doesn't. That's not arithmetic or geometric. It's a sequence of numbers, but there's no commonality there. It's not arithmetic. It's not geometric. It's just a sequence of numbers. 1, 1, 2, 6. Not a geometric. This one, 7, negative 70, positive 700, negative 7,000. Can you see what it's doing? It's multiplying by negative 10. 7 times negative 10. Negative 70 times negative 10. 700 times negative 10. That is a geometric sequence. This one's multiplying by 5. That's a geometric sequence. Oh, that's all. Okay. So as long as you can recognize what a geometric sequence is, we'll be able to do these formulas. And it can be in different forms, just like arithmetic sequences. We could have a list, 1, 3, 9, 7. It could be a table. The first term is 1. The second term is 3. The third term is 9. The fourth term is 27. See, there it is as a table. Here it is as a graph. The first term is 1. The second term is 3. The third term is 9. The fourth is 27. Notice there's no line connecting that graph because we don't have a 1.5 term. We don't have a 3.2 term. We only have a third term and a fourth term. This is not continuous. It's just points, a discrete set of points. There's spaces. It's a discrete. All right, so there's 2 methods for determining the terms of a sequence. Recursive, just like there was with arithmetic. If we know the number before it, we can multiply it by the common ratio. Right? If we know the one before it. If we know that the fourth term, a sub 4, is 64, we can multiply it by the common ratio, which in this case is 4. If we multiply a sub 4 by 4, we'll get the next one, 256, by multiplying 64 times 4, because we know what a sub 4 is. So that's the recursive way. Explicit's when we jump straight to it. Like, what is the 10th term in this sequence? Well, if I knew the 9th term, I can multiply it by 4. Well, we'll come up with a formula that helps us jump straight to it. All right, let's look at page 3. Just like we did with arithmetic. All right, so it says, okay, let's say we have this 2, -6, 18, -54. Right, and we want to know what the 11th term is. We know the first 4. So we know the first term is 2. So we got that filled in. First term, 2. Second term. To find the second term, we know the common difference is being multiplied by -3. So we'll take -3 to the first power, because this is the first time we're doing it. 2 times -3 to the first power is -6. Second term. So the third term, we need to take -6 times 3, or we can go back to that first term and multiply by -3 twice. 2 times -3 times -3. And that'll take us straight to the third term. See, or we can take the second term, which already has been multiplied by -3, and multiply again. So it's really -3 to the second power. For the fourth term, we can take the third term and multiply it by -3, which means how many times have we multiplied by -3 now? We've multiplied 3 times by -3. So notice there's a formula starting to come in here. So where does the 2 originate? Well, the 2 was the very first term, right? So if we look at the answer, 2 is the first term. Where's the -3? Well, that is the ratio. That's the common ratio. If we divide a term by the one in front of it, we get -3. How is the exponent determined? The exponent right there. Well, that's how many times you've multiplied the first term by -3 to get to the term you want. The fourth term, you're going to multiply 3 times, n minus 1. If we want the 8th term, it would be 7 times. The exponent -3 comes to position the term in the sequence -1. Fourth term, we did it -1 3 times. So what's the 5th term? 162. Because you can take 54 times -3. -54 times -3. You get 162. So going backwards, they have a video where they're going to take that apart. But let's do that on paper. You can watch that video anytime. So they're available for you. So if we have 2 to the -3rd power, and the 5th term, we did it 4 times, right? So we take the first term times -3. That gives us the second term. Do another -3, gives us the third term. Gives us the fourth term. Gives us the 5th term. So that means it's -3 to the 4th power, because we're 1, 2, 3, 4 times multiply it times itself. So we have a formula that says a sub n equals the first term times the common ratio, whatever the ratio is, to the n minus 1 power. Hey, geometric sequence. This is the formula for a geometric sequence. If you know the first term and the common ratio. There's our notes right there. A sub n equals the first term times the common ratio raised to the power of n minus 1, whatever term you're looking for. whatever term you're looking for. So when this sequence we had 2, -6, +18, -54, that's the one they gave us. If we want to know what the 10th term is, we can take the first term, which is 2, common ratio is -3, and n minus 1 is 9, right? Since n is 10, we want -1. So we can get out our calculator and say, okay, what is the 10th term? 2 times -3. I have to do the negative afterwards. -3 raised to the power of 9. So the 10th term in that sequence be -39,366. And it makes sense that it would be negative because if we look at that, the second term's negative, the fourth term's negative, so the 6th term, the 8th term, the 10th term, it should be negative. All right, so that gives us a formula to take us straight to the 10th term. That's the explicit formula then. And you can see this video where they kind of work that through there, starting with their A52 and working backwards, but they'll come up with the same formula. Here's the formula right here. A sub n equals the first term times the ratio raised to the power of n minus 1. And we know what all the variables are. N is the term number you're looking for. R is the ratio. A sub 1 is the first term. So A sub n is the nth term, whatever term that is. All right, so the other formula, of course, this was the explicit. The recursive one, if we want to find A sub n, we just take A sub n minus 1. It's not a very good. Times the ratio. Right? So if we want to know what the 5th term is, we take the 4th term times the ratio. That's the easy one. First, second, third, fourth. If we don't know what the 5th term is, we just take this 4th term times -3. And that'll give us the 5th term. So that's our two formulas. If you know the term before, you can just take it times the common ratio and find out what the next term is. If you don't know and only know the first term and the ratio, you can jump straight to any term using this formula. So there's our two geometric sequence formulas for our notes on how to find a number in a geometric sequence. And they have those at the bottom of page 3. They put the ratio first. That's fine. Ratio times A sub n minus 1, or the first term times the ratio raised to the power of n minus 1. All right, what do they have on page 4 here? Combination of functions. Yeah, it's really two parts. You have the A1 part and then the ratio raised to a power part. A1, that's a constant, that's a number. It's whatever the first number in your sequence is. It's just a constant number. This is an exponential expression. R raised to a power, that's an exponential equation. So it'll grow faster the bigger the number is. And we multiply those together, that gives us our geometric formula, the explicit formula. Domain and range, again, we can talk about that real quick. What is the restrictions on that? Well, this number could be anything. We've seen it could be a positive, it could be a negative. They get really big. So, the range of it is anything. But the domain, the n, can only be counting numbers. 1, 2, 3, 4, 5, right? We can't find the 0th term of the sequence. We can't find the negative 4th term. For this sequence, what's the negative 3rd term? There's not a negative 3rd term. That's like looking at a bunch of people in line and say, okay, who's first in line? I see who's first in line. Who's negative 3rd in line? There's not a negative 3rd in line. We're talking about physical counting numbers. I can tell who's first in line. I can tell who's fifth in line. I can tell who's 29th in line. I can't tell who's 0th in line. So we're restricted to n is greater than or equal to 1, and it's only integers. There's not a 1.5 person in line. So, all right, here's some examples that you can work through. Find the 14th term. If you know the first term is a 6, and the 8th term is negative 468,750. And you're like, oh, how would I do that? Oh, all I've got is the first term and the 8th term. Well, we got to figure out what the R is. All right, we got to figure out what the R is. So let's do this one as a practice problem together, because I want you to be able to understand how to use these formulas. A1 is 6. A8 is negative 468,750. What is R? All right, so how do we do that? R is what? I don't know. We got 8, we got 1. All right, so looking at these formulas, this one we could have A8, but we'd have to know A7. That doesn't help. This one, we have the first term. So if we did this, A sub 8, we know is negative 468,750. A sub 1 is 6. And it's being multiplied by R, which we don't know R, but we know what n minus 1 is. Since this is the 8th term, this will be to the 7th power. So we know if we took the first term times the ratio to the 7th power, we'd end up with the 8th term. So we just have to work backwards. We're trying to get R by itself. So we divide by 6. Okay, well, we may need a calculator, but we can divide that by 6. So if we have 468,750, and it's a negative. So there's a negative. And we're going to divide that by 6. That is negative 78,125 equals R to the 7th power. We're closer, but we need R, not R to the 7th power. Well, if we take the 7th root of both sides, the 7th root of R to the 7 is just R. So here's what R equals. R is the 7th root of this big negative number. So let me go to shift on my calculator. There is the root with a little y. I can say what root. It's not square root. It's whatever root I want. So if I want the 7th root, it's negative 5. Negative 5 to the 7th power should be this number. So let's test that. All right, so negative 5 taken to the power of 7. Yep, that is negative 78,125. So negative 5 to the 7th power is that number. So the 7th root is negative 5. We found R. There's our answer. Find R. They get there. They got all the work, but there it is, negative 5. And then to find the 14th term, they want to find the 14th term. We just put that into our formula now. A sub 14 is 6 times the common ratio of negative 5 to the 13th power, because 14 minus 1. Put that all in the calculator, and the 14th term is negative 7,324,218, 7 billion in it, negative 7 billion. So it's a big number. That's just the 14th number in the sequence. But when you're multiplying by negative 5 every time, things get big in a hurry. All right. So here's another one you can practice. Round the solution to the nearest hundredth. That's 2 decimals. And there's the lesson summary. So this wraps up all of our geometric sequence formulas. There's the recursive and the explicit. All right. So this one is the explicit. And it talks about the domain is restricted to integers greater than or equal to 1, the counting numbers. All right, let's look. There's more practice problems if you need them, and you should practice some of them. You should do this on paper and see if your answers match their answers. So you make sure you're doing it right. Find the 10th term of this sequence. See if you can do that. Submit. There's 5 of those for you to practice. All right, let's look at the assignment that goes with this. Geometric sequences, 3 attempts. So if you don't do well the first time, figure out what you did wrong there, or come to class Friday and ask me. Identify the 16th term of the sequence. It gives you the first term and the 8th term. That's like the one we just now did. Find the 19th term, where the first term is this and the 9th term is that. Round it to the nearest hundredth. That's 2 decimals, just like they have 0.80. Hundredth. And if it's off by just a number or so, that's just because of rounding. So maybe your answer is 13,187.1. Well, looking at these choices, that's pretty close to 185.66. So it's just a rounding error. You would choose that. I don't know what the answer is. I haven't calculated it. I'm just saying as an example. Here's a bacteria that doubles every hour. So how many hours are growing during the 12th hour? If it doubles, there's your common ratio. Given the functions f of n equals 11 and g of n is 3/4 raised to the power of n minus 1, combine them. How do you combine geometric sequences? Do you add them, subtract them, multiply them, and then find the 9th term? And then this one, they just want to know what is the explicit formula. If the first term is -4, second term is 20, third term is -100, and what restrictions to the domain? Is the domain greater than or equal to 1 or greater than or equal to -4? So if you know the domain that we talked about just a minute ago, you can throw out 2 answers already. All right. There it is, guys. There's your geometric sequences formulas and your arithmetic series formulas to add everything up. So guess what we'll be doing next week? Yes, geometric series, learning how to add up these geometric sequences. So, all right, guys. Again, class is not mandatory on Friday, but if you start on this, which you get the rest of this period before your next class, you can come to class Friday if you need help. So if you work on this before Friday, then you'll know, do I need to go see Mr. Broad and get help? Or do I know what I'm doing? Because I did the practice problems in the assignment and I nailed them. I know what I'm doing. Guys, have a great week. If I don't see you again Friday, then I will see you next week on Monday. All right. Talk to you later.